Okay, so the next one in 4 dimensions would be, if we were going to do the whole thing, would be 1, 2, 3, 4.
Yep. There's 24 of those.
Right, and there's 24 permutations of 1, 2, 3, 4. The designer of this, and I'll write about it in the blog post. I just forget the name right now, but I got this off Thingiverse. I did not make this. The designer didn't use 1, 2, 3, 4 to make the coordinates look better in the projection. I think, if I remember right, it was 1, 2, 4.2, and 7. But how many permutations are there?
It's still 24.
Still 24. So I'm just going to say 1, 2, 3, 4. And so each vertex, and can you count how many vertexes there are? Can you see?
So there's
How many
6.
vertices there are?
6 on the top.
Yeah.
6 on the bottom. There's 6 around this middle
18,
bit.
24.
Right. See,
Yeah.
you see 24.
Yep.
It's odd because it's not symmetrical. There's a large one on the top here.
Uh-huh.
There's a large hexagon, and then there's a small one on the bottom, and then there's all large ones.
Yeah.
There's only one small one.
Well, are you sure?
No, is this
There's
small
a
one, small one here,
Yeah.
and small one here.
So
Yeah.
the large,
Just-
actually,
The large and the smalls are sort of
you can
wait, no.
make.
there. There's, I think there's 6. There's small one, small one, small one, small one. There's 4.
But the small ones are actually made of the large ones vertices. So
You can make
outer, there's the outer 2 vertices. This one of this hexagon, this hexagon, this hexagon, and they all come together.
Okay, so there's a couple different ways we can see that there's 24 vertices.
Yeah.
But they're not all connected to each other. And in a regular, how many connections are there on each vertex, by the way?
So, let's see, 1, 2, it looks like there's 6. 6 connection. 1, 2, 3, 4.
I see 4 or 5. 1. Are you counting the one that would be the side?
Mm-hmm.
All right. So 1. I'm doing this one here. 1, 2, 3, 4, 5.
Okay, how many do you count?
Well, I see 6 because there's the 5 on the outside. 1, 2, 3, 4, 5 here.
Okay.
And then there's the 1 going
Oh.
in. 6.
See that one there?
Okay. So each vertex, that was harder to count than I thought. 1, 2, 3, 4, 5, 6.
Sort of hidden because if you're looking at it right on, you can't see it.
Yeah. That's interesting. So each vertex connects to how many?
6. 6 other vertices.
Yeah, each vertex connects to 6 other vertices. Okay.
Yes.
And so the rule for making this is we're going to connect when exactly 2 points are the same. So this might connect to 1, 2, 4, 3. Actually, it's probably not exact. Well, I don't know.
Well, but would something like 4, 1, 2, 3 connect to this point?
Ah, interesting question. 4, 1, 2, 3. Does that share exactly 2 coordinates?
Yes, but they're not in the same place.
Okay. So does it
But
share them?
It's still well.
No, it
No.
doesn't.
No. It doesn't. So the question is, how many of these, how many ways are there to share exactly 2? So I gave you one example, 1, 2, 4, 3. Give me another one.
Well, you could do like 1, 3, 4, 2.
1,
They don't have to be adjacent
4,
necessarily.
2. How does that share 2 with this?
Or I said 1, 4, 3, 2.
Okay.
Because it would share the 1 and the 3.
1, 4, 3, 2. Okay, so that shares the 1 in this.
If I said 1, 3, 4, 2, I was looking at this one.
Okay.
Also, for the top one, you could have 4, 2, 3, 1. 2, 3, 1.
Sorry about that. 4, 2, 3, 1. Okay.
Well, how many of these would there be?
Yeah, good question.
So, you can, I guess you can choose 2 of these numbers to share with our starting thing.
Okay, so how many are there going to be?
So there's 6 ways
How did you figure that out?
because it's 4 choose 2.
Okay. So we first we shared 1 and 2, then we shared 1 and 3. So maybe another one we could share would be
1 and 4.
1, 3, 2, 4. Shares 1 and 4.
And
Then we shared 2 and 3.
And we
share
should
2.
2, 4. And
And
then
share 2 and 4.
then 3,
share
4.
3 and 4.
And we could share 3 and 4.
But there's only these 6 because you chose the 2.
Yep.
Now you have the other 2 numbers which you can arrange in 2 different ways.
Uh-huh.
But one of those ways just gives you this.
One of our ways would be the same vertex,
Yeah.
right? So that's why each point connects to 6 other ones. And we get this very interesting shape.
Yeah.
And we're going to do one, I probably went long on that, yeah, 6.5 minutes. We're going to do one last thing, okay?
Okay.
Okay.